And let's keep going with reviewing our audio prototype. And I'm Artem Demon, a sound designer and implementer for video games. If you need more context on what I'm doing here, then I recommend you to watch first introduction / overview of the project video. Just to remind you, I'm showing off some custom audio tools and implementation techniques for Unity, and now we have a dynamite, which is one of the most interesting features in here. And let's run away from the zombie chasing us, because we moved our player character. So the dynamite, we can spawn it. It explodes, obviously, and notice how it explodes after 4 ticks with a certain rhythm, 120 BPM to be specific at the moment. Also, if we are too close to the dynamite, or more like if the audio, if the explosion audio is too loud for our play character, then you'll see what happens. We get tinnitus sound, and the world audio becomes muffled, so notifying that our guy didn't like it. Also, we can destroy our enemy with this dynamite. And just like that. So yeah, let's check what it looks like from the inside. So here is the prefab of the dynamite. We have a default audio, which is just this crackling fuse sound. Nothing too interesting in here. Yeah, this dynamite is actually pretty improvised, made of just one red cylinder and some sparkles. But yeah, in terms of audio, we have this script attached. We have this script as well, but it's gonna be for another video. So right now it doesn't really matter. So we have this script attached, and it basically handles both the visuals and the audio aspects of the dynamite, because I initially considered it as an audio feature, like just an audio feature, but yeah, now it has some visuals. And so yeah, what we have here, we have 2 audio sources: click sound, boom sound. Let me quickly show you what the click sound. What the click sound looks like. Well, just a single click, nothing more, and it's not a pre-recorded sequence, so you've heard 4 clicks with a certain rhythm. So these are single clicks, and we have this Unity random container for the explosion sound, just like that. I really like this sound, by the way. It's from the library, and what parameters do we have here? We have a BPM, so we can control the rate of the ticks, and boom, we have 120 BPM. We can lower it down just for the sake of showing what's going to be, and put the tick count to 2. So we'll hit 2 ticks before the boom. Let's save the prefab, and so you hear now that the clicks are slower, but we only hear 2 clicks before the boom. So we've checked the public variables now, which are here. You can see them. And here is what it looks like. So we have this handle beats function that is responsible for the sample accurate audio So we use play shuttled to make sure that we don't play it that we play it at the right time, all the clicks and the boom sound. And what problem does this solve is that if we were to like measure with uh, maybe seconds or something like that, it wouldn't work this way. So we will have to probably tweak a lot, or maybe most likely we'll probably won't get like sample accurate like audio playback. So that's the method that I've used in order to ensure that everything works as I wanted. So we can like predict exactly when the boom is going to happen. So yeah, and one interesting thing that uh, when the explosion, the explosion happens, we start the audio analyzer on the boom audio source, so on the source of our explosion. And let me quickly show you what it's all about. So we have this explosion loudness analyzer. This actually involves its own script, which is pretty complex. It uses RMS to measure the audio level. Basically, the logic is that we pass a certain audio source, and we set the time right here for how long are we gonna like measure the audio level. We start like the analysis, and yeah, so we check if the threshold was exceeded. We also have some like features to reset the threshold exceeded, like when we want to reuse the same analyzer, because yeah, okay, that's for the future. So yeah, we basically start measuring the audio, check if the threshold was exceeded, and in another script, we can like context this loudness analyzer and check what output does it have. So we can track whether the threshold was exceeded, and if it was exceeded, then we can do certain actions. Certain actions in this in this scenario are triggering that tinnitus sound and making the word audio muffled. So we have that's another script called like tinnitus tinnitus low pass filter. And what we have here is we have a word mixer reference here. Here, let me show it to you in the context. So we have word, and we have a low pass filter with exposed parameter, so we can use it in our code. Yeah, again, I want to mention that I'm not an audio programmer, just in case. But yeah, I do have some programming background, so excuse my my terms, the terms that I use. Hope they make sense. So we have effect control parameters, which are which are related to like this world low pass filter. We have a default value, which is like 22,000 hertz, which is like uh, above the average human hearing capabilities. Yeah, we have a target effect volume. We have like 1,000 hertz. So that's how muffled our audio is gonna be. So we cut all the frequencies above 1,000 hertz in here. We have time to target effect. So how quickly is it gonna come from 22,000 to 1,000? We have some time to hold the effect where we like do nothing with it and keep the audio muffled. We have time back to default, so I gradually increase it back from 1000 to its default value. And the same thing for the tinnitus sound, pretty much the same. So we have a default volume 0 because we don't want to hear our tinnitus most of the time, only when uh, an, an undesired event like exploding the dynamite close to us happens. We have target volume, uh, time to get to this target volume, similar to like the effect parameters, time to hold and time to get back to default. And we have a loudness analyzer reference in here, which is this loudness analyzer. Yeah, you can see the script right here, where we control the tinnitus and the volume. So basically, the idea that with like this tinnitus event is that the explosion happens. We ask our loudness analyzer to start analyzing the boom sound, the explosion sound, and if the threshold is exceeded through this script, we launch the tinnitus sound. And to be honest, in the real life scenario, I would probably just add a collider and like check if the explosion happened like close to us. If we like overlap with the collider when the explosion happens and then trigger the tinnitus, it would probably be more like stable and more like more easy to configure, I would say. But here I'm just like showing like the audio features, so that's why it works this way. So in reality, I would probably use this feature for something like triggering zombies, for instance, when we are like too close to them, and when we are not too close, when we make like loud noises, loud footsteps, or something like that. Yeah, and you can notice that this loudness analyzer has an array of audio sources, so we can pass several audio sources at once, up to 5, if I remember correctly. At the moment, that's just because I don't need more than 5, but you can make it a public variable eventually and add as many as you want. But yeah, I haven't tested how stable it is. And yeah, we also like remove the audio sources that doesn't have audio. What it's called? Audio clips. Now it's called audio resources to be honest. So yeah, audio resource right here. So yeah, it's pretty much manages itself. So uh, to make sure that excessive work is not done throughout like working with it, if that makes sense. But yeah, I'll review it in more detail in the future. For now, we just like check the features of our dynamite. And yeah, as for like the sample accurate audio, let's get back to this one. Um, it's useful for triggering music because we need like when we have some music loops, we need some sample accurate timing. And that's why we need to ensure that each of the like music track is played where exactly when it's needed, with no like skips and stuff like that. And I guess that's it for the dynamite. Thank you.